Hello, welcome to module 18. This is the last module in this course, and it will talk about performance testing and also concept of security and reliability testing, which is the last bit of what we're going to learn in this course. Okay, so let's get started with the first one, performance tests. So the concepts that are related to performance testing, there are four main concepts. The first one is called throughput. The second one is called response time. The third one is tuning. And the last one is benchmarking. We're going to talk about each one of them one by one. So throughput is the capability of a product to handle multiple transactions in a given period. Okay, so the key thing is that how many transactions can occur in a given period of time. That is called a throughput. So it's the number of requests or business transaction in a specific time duration. So for example, how many requests that you can accept per minutes. Okay, so if it's a web, you might think about throughput like this. If it's a banking app, we might think about throughput as the number of transactions per minute or per hour that the system can accept. All right. So the concept of throughput is the number, how many transactions, how many requests that you can do per a specific period of time. The second concept is called response time. So the response time is the different aspect from the throughput. The response time is how much time each of the transaction take to complete. So this is time. You can measure it in terms of seconds, minutes, hours, so on and so on. While in the throughput, it's the number of responses or the number of transactions. All right. That's the key difference. So this is the time. And the response time is the lower, the better. Because you want the system that is pretty responsive. So the lowest response time is the most desirable one. Okay. So usually you cannot get like zero response time. There will be some delay between the point of request and the first response that you will get from the product. Okay. So let's say for a web application, it might take a second or two to load the page, right? So there are tools that help us to do this kind of measurement of the response time, and the tool is called a Google Page Speed Insights. Okay, it will look something like this. When you open the tool, it's a web application tool, and then you enter the website that you want to measure the performance, which is the response time. It's gonna try to load the page, and it's gonna analyze the result. Okay, I put the link here, so let's try it a bit. Just a moment. Okay, so let me copy it. Okay, I'm gonna put in the URL. Oh, okay, sorry. The URL is wrong. Page speed inside. Okay, so let's go to ict.mahidol.ac.th. Let's see if it works. It's gonna run some analysis, right? So this is when it starts to load the web page, and it reports both the mobile and the desktop version. So you can see that the score is pretty good. The web vital assessment is passed, and then they're gonna try to diagnose some of the performance issue. Okay, let's see some of the measurements here. There are some largest contentful page, this one, LCP, interactions to the next pane, so on and so on. So how the web is being rendered in the web browser. The time to first byte is 0.5 seconds. That is like just half the second, then you get the first byte, right? And then when it finishes the performance issue, we will see that the performance is not pretty good. It takes a few minutes to load the whole page, right? So you get 67 as a score out of 100. So the first contentful pane takes 1.2 seconds, and the largest contentful pane takes 3.7 seconds. And the speed index is something close to 5 seconds, which is not a very good interactive and responsive website. So we might improve our faculty website based on this result. Okay, so that is response time, right? The next one is called tuning. So tuning is not a measurement, but it is a procedure that we try to improve the performance of the system by setting different value to the parameters of the product. So you try to tune the parameters, the configuration of the product, and we try to improve the performance without needing to change the implementation or the source code. Some of the parameters or some of the configurations might strongly affect the performance. So you can try to do tuning first before actually changing the source code. All right. So the concept is that you must have some baseline. Let's say the first version of the software, and then you collect the data to know what is the performance. And then we try to analyze the result, and then we try to change the configuration. And we test again, and then we compare with the baseline that we have to see whether it's improved or not. The next one is called the concept of benchmarking. So benchmarking is the way that you compare the performance of your product to other competitive products. So if we know that we have some competitors, you can try to do benchmarking with them to see whether are you doing well or not in some aspect of the performance. Okay, so for example, one of the software products that are doing a lot of benchmarkings are the browsers, right? So every single year, there will be the browser test and there will be the result of which one is the best one. So this is just an example. We can see that in terms of the, let's see, in terms of the memory usage, the one with the lowest memory usage is Microsoft Edge. But in terms of the HTML5 test score, the blue one, they got pretty very similar score, right? But the highest one is also Microsoft Edge. In terms of the storage usage, the lower the better. The best one is Mozilla Firefox. So this called benchmarking. So you try to benchmark your product with the competitors in multiple aspects and see where are you in this comparison. So what is actually the performance testing? We know some of these concepts. So performance testing is when we try to evaluate this response time, throughput, and the utilization of the system so that we can check whether it satisfies the requirements. And we compare with different versions of the same product or compare with a different competitive products. Okay, this is a non-functional test because it checks for the non-functional requirements that you have. So you can do this kind of performance test until you are satisfied or the system is achieving the expected level of performance that you're aiming for. And this should be done after you have built the whole thing. You have built the whole system, you have done the system test, and then you can try to optimize based on this kind of performance testing. So usually when we do performance testing, there are several different testing types. The first one is called a smoke test. So smoke test is when you want to just check whether the system is working based on minimal load. It's a pretty simple check that the system run and can work. At least it's up and running, right? The second one is called average load test. So this one is you do the test by based on the normal condition. So normal throughput, and then you check whether it still works as expected. The next one is stress test. This is when you try to push the system at its limit. Okay, so you try to add the load beyond the expected average. You might aim for the system to accept 1,000 requests per minute, but you can try to push it a bit to 1,500 or even 2,000 and see how the system behaves. The next one is called soak test. This is when you kind of push the request over a long period of time. to see whether the system can withstand the long concurrent requests over a long period of time. The next one is a spike test. So spike test is when you try to have a sudden short, massive increase in the activity. So you get a very huge throughput coming out to your system in a very short time, like a big spike like this, right? So this is called a spike. So when you have this kind of spike test, you can see whether the system can tolerate a huge amount of requests in a very short time. You can imagine when the system like คนละครึ่ง or the system like reserved for the ticket or a concert open in the very first minute or the first second, then it is this spike test that there's a lot of requests coming in together at the same time. And the last one is called a breakpoint test. So the breakpoint test is when you gradually increase the load, okay, to see where the system break. So you keep increasing the load, and then to see when the system actually cannot accept any more requests, right? So if we look at these kind of testing types as a graph, we would have the following. So the smoke test is a minimal check. You can just run it. So this is time, and this is the amount of throughput, right? So the smoke test is you run it just for a very short time with a very few amount of throughput, just to check that the system is working. And the average workload is when you have simulated the actual workload of the system with the average amount of throughput over some particular time. Then if you want to do stress test, sorry, we increase the amount of throughput a bit to be beyond the average and slightly longer than the normal average load. When we do soak test, we're going to have the average load, but it's going to stay for a very long time. Okay, so this tests whether the system can withstand this kind of long consent request. The next one is called the breakpoint test, where you just keep growing the number of throughput up to the point that the system cannot no longer accepting those requests, and that's your breakpoint. Okay, so this is to know the limit of the system, how much it can accept. And the last one is called a spike test, where you have a really high number of throughput in a pretty short amount of time, a big spike here, and see whether it breaks the system or not. All right. So there are multiple tools that can help us to do this kind of performance testing, both open source and commercial tools. Okay, so the open source one, we might have, we can have open STA, D-cell test, testmaker, grider, load sim, JMeter, one of the popular one, Rubis, and Grafana K6 that we're gonna talk a bit in more detail. For the commercial one, we have HP Load Runner, Silk Performer, Q Engine, Empirix, eLoad, and many more. Okay, so there are actually many more tools. So this is just some example of the tools. So the step for doing performance testing is, first we identify the testing environment, and then you identify the performance metric that you're going to choose. You plan and you decide for the test, which type of test, the metrics that you're going to use, how did you set up the system, so on and so on. And then you configure the test environment on which server, how this is deployed, so on and so on. And then you implement the test design, you execute the test, and then you analyze the result, and then you keep repeating the process. All right. Okay, so next is the 5 common performance testing mistakes. First thing is that many people think that they don't have enough time to do this kind of performance tests, but actually this has a lot of effects on the users, right? So this is something that you should reserve the time at the end for. The second thing is they don't involve the developers in the performance test, and without having the developers, then it's difficult to fix the system to get a better performance. The third one is they are not using the QA system that are similar to the production system. With this kind of different setting, the performance test result that you have might not actually reflect the true production system when you deploy the software. The fourth one is you don't have sufficiently tuning the software. So some of the performance can be getting better just by doing tuning. And the last one is there is no troubleshooting plan. So when you have any problem, there is no step on what to do after that. Okay, so next I'm going to talk a bit about the tool that can be used for doing performance tests. And the tool that I'm going to talk about is Grafana K6. So Grafana K6 is released in GitHub in 2017, and it is written in Go language. Okay, so you can write a script, and it supports JavaScript as well. The important components in the K6 is that you can setting several kind of options for doing performance tests, like virtual users or stand for VUs here, the duration of the test, and many stages in the performance test. You can also define checks and also threshold and get some metrics from the test. Okay. So the VU stand for virtual users. So this is the simulation of the number of virtual users that will be using your software in a specific amount of time. So you can set it like 1,000, 10,000, 100,000, for example. The second one is a duration. So a duration is the total duration of the test that should be run. So you can set 6 minutes, 10 minutes, 1 hour, so on and so on. And the stages is the array of objects that tells when is the number of virtual user will go up, when the number of user will go down. All right. And the checks in Grafana K6 are very similar to doing assertion in unit tests. So the check can result in either pass or fail. So that means the test passes or the test fail. And you need to use the check with some of the actions. Like the check will check whether the response status from the test is 200, which is the normal okay response. And you can check whether the size of the header is correct or not. And you can check even deeper, like the header includes some specific text or not. And the threshold are the one that used to specify whether the test pass or fail. So you set the threshold using some metrics. For example, the HTTP request failure rate. So this is the metric. And this is the threshold. Okay, so the HTTP request failure rate must less than 0.01%, or the HTTP request duration must less than 200 milliseconds. And the metrics can be many things: response time, wait time, average load time, peak response time, or the error rate. Okay, so each one of them has their own definition. Like the response time is the total time to send a request and get a response. Wait time is how long it takes to receive the first byte after you send the request. The average load time is the average amount of time that the system takes to deliver every request in general, right? And the peak response time is the longest amount of time that it takes to fulfill a request. And the error rate is the number of the percentage of results, the requests that result in the errors compared to all the requests. Okay, so these are the metrics that you can use and set up Grafana. And there are many more metrics that you can check from the documentation of K6. The last thing is security and penetration tests. So security test is also another important aspect of system tests. So the security test will focus on the negative scenarios, like the misuses and the abuses of the system. So for example, you can check for authorization, whether the correct authorization is granted or not. You can try whether you can do illegal reading of the file when it is not allowed, so on and so on. Okay, so these kind of security tests will make sure that your system is hardened enough to protect from the malicious people to attack your system. And specific type of test is called a penetration test. So the penetration test try to find some loopholes in the system or what's called the backdoor that other people can sneak into your system. And there are many tools that can use for this kind of security tests, and they can be categorized into multiple types like static analysis security testing tool, dynamic application security testing tool, origin analysis, software component analysis, mobile app security testing, so on and so on. And the list of tools, for example, Metasploit, OWASP software, Kali Linux, so on and so on. All right. And the last thing that we're going to talk about in this module is the concept of reliability. So what is reliability? Reliability is when we expect something to behave in a certain way. And when it behaves in such a certain way, we say it is reliable. Okay, so we use this reliability as one of the measures of the quality of the software. So if the system behave in a certain way, it stay up and running and giving services as you expected, then we can say it is reliable. But when it's getting down a lot, it cannot serve the request on and off very, very often, then it is not reliable. So the system without fault is usually considered to be highly reliable. And the key concept that we're going to discuss about reliability are as follows. We're going to discuss fault, failure, time, and then we're going to discuss the 3 interval that relates to reliability. Okay, so let's do a quick recap of what are failures, fault, and time. So failure is the external observable outcome from the program execution that is not as expected. Okay, it's an external so the user can see. The fault is the problem in the code, right? So the fault is the problem in the code. But the fault is the one that leads to a failure. So a defective block of code is a fault and it generates the failure. And the time is the gap between 2 failures or the time between the recovery of the failure until the next failure again. Okay, so we are talking about 3 durations. Okay, so let's start with the first one. When we measure reliability, we can use first MTTF or mean time to failure. Okay, so let's look at this diagram here. So let me zoom in. So this diagram shows a system, and this is the time aspect. So the times go from left to right. And this is the start of the system operation. So the arrow shows that there is a failure. Okay. And the dotted arrows is when the system has been repaired and come back to work. So first, if we focus on MTTF, it means mean time between failures, right? So the mean time between failures, sorry, MTTF is mean time to failure, right? So mean time to failure means when you have the system that's work until it is not working. So this is a time to failure. Okay. Another one, when the system has started recover and then it goes to another failure. This is another time to failure. So you keep calculating this. Okay. So I have multiple. This one doesn't have the failure yet. So I have multiple time to failure. So this is another one, TTF. And this is another one, TTF. Okay. So when we have this and we find the average or the mean, right? So you find mean of all the TTFs that you get. You're going to get the value of mean time to failure. That is the average time that the system that is up and running go to a failure state. So how long it takes for a system to become failure. Okay, so that's the first one, MTTF. The second one is MTTR, mean time to repair. Okay, so for the mean time to repair, it's a different thing. So let's say we have this time that the system is up and running. Sorry, the system has a failure. And then this is the time where the system got repaired. So this is time to repair. Okay. The next one is this one. So this is another TTR. This is another TTR. This is another TTR, and this is another TTR. So if you find the mean of this, you're gonna get mean time to repair. The mean time to repair is supposed to be short because we want the system to be up and running very quickly, while the mean time to failure should be very long. It's supposed to be as long as possible because we don't want the system to be in a failure state, right? So that's the second one, mean time to repair. The third one is called mean time between failure. So this means from one failure to another failure, how long does it take? And this is supposed to be very long as well. And it will be equal to the sum of MTTF and the MTTR. Okay, so if we come back to look at this diagram again, and this will be the first failure, right? And this is the second failure. This is time between failure. You have another one, another failure. So this is another time between failure. Okay. So time between failure are the mean of this thing. Okay. So if you find the mean of the time between failures, multiple one, then you will see the average of how long does it take from one failure to the other. Oh, I think I forgot a few of them. So there are actually this one, another TBF, and also this one, another TBF, right? So oops, too big. So these are the time between failure. Okay, this one, this one, this one, and this one, right? So let's recap again. Mean time to failure takes the time from the recover state to the failure state. The mean time to repair start from the failure state to the recover state. And the mean time between failure start from one failure to the next failure, and then you find the mean. Okay, these are the measures that can be used for calculating the reliability. So you want the MTTF to be large, MTTR to be small, and MTBF to also be very large. And that's all for this module. We talk about performance tests, many concepts, throughput, response time, tuning, and benchmarking. And we talk about the tool that we can use for doing performance tests like Grafana K6. And I discussed security and penetration tests and also reliability concept. And this is all for this module. And this is also the end for the course, software quality assurance and testing. So thank you so much for taking this course, and I hope the course is useful for you. See you again soon. Bye-bye.